And now it's time for last talk from Kalindi Fonda. And so, Kalindi, if you are ready, I will hand it over to you.
Hello, everyone. I'll talk to you about our project Spyfish Aotearoa, but also give you a little note on the International Conference, Conservation Technology Conference earlier this year. So let's jump right in. So what is Spyfish Aotearoa? It's basically an effort from Wildlife AI and the Department of Conservation in New Zealand to streamline and automate marine protected areas reporting with machine learning, citizen science, and experts. And so how do these surveys happen, or like how does reporting happen? Basically, this is how the surveys used to happen before, and it's the Department of Conservation in New Zealand records some videos with having bited, like, drops down a frame with some bait, and they do this in more than the 40 of marine protected areas around the country, and then there's multiple drops in each location inside and outside the marine reserves. Previously, this was done writing like on papers and on Excel sheets, and then things were uploaded on SD cards and hard disks. So it was, and each of these was happening independently in each of the marine reserves. And then the rangers would review these videos. Each video was 30 minutes per drop. So they were about 1,000 hours of videos per year. And the number that we want to get out of that is basically max number per species per video. So it's a lot of human time for one or a few numbers. And also, as mentioned before, it was all around the country. So if you want to find some number from a few years ago, you have to write an email to someone and so on. And then reporting would happen by combining all this info and sharing. This is our data. So as mentioned, there's like a bait in the middle, and then there's like fish that come to eat. So a few years ago, we had this idea that instead of there being a ranger doing the manual task of reviewing the videos, we could do a little bit of machine learning. However, it's not so easy, because what data do we put in this machine learning, and where does it come from, and how do we collect the new data, and where do we store it, and then how do you run this machine learning repeatedly, and how do you ensure that the annotation is like of good quality? And then also, once you get the machine learning output, what do you do with it, and how do you put it all together? So our little machine learning project became this much bigger system, and I guess we're very excited because it's actually now working. Like it works from the beginning to the end, and we are in the iterative process of making it better and improving. So that's a great step of any project. So I think one thing that we learned from this is that already just cleaning the data and centralizing. So basically, this upper part was a big win. So we did basically three things. We standardized, centralized, and normalized the data, which means standardizing, it's like naming standards, and then like in the field, inputting the data with apps instead of paper, and then like have video file names that are uniquely identifiable, and centralization, basically bringing all the data in one spot so that we can look at it and have dashboards. And then normalization, also making sure no repetitions. I'm sure you all know when you have Excel sheets and teams try to share these Excel sheets, there's all these like versions and things go out of hand very fast. And then we also, one benefit of that is that we can create like automated and manual error checking. One thing that we learned also is that it's good to have a drop ID, or basically our data being the video. We want to have a drop ID that is uniquely identifiable, because often when data is sent back and forth, what happens is people lose metadata and information about that video. But by creating this ID out of all the information, basically the metadata itself, that kind of helps keep track. And also if someone sends something somewhere, or someone finds a data, a file somewhere, we know how to trace it back. So also then when we have frames, we just have the same with like a frame second at the end. So one of my favorite things about cleaning up the data is that even before doing machine learning, you have wins. So for example, if you plot your inside the marine reserve and outside the marine reserve dots on a map, you can see what's happening. And I'm going to look at the chat, what people are saying. Do you see what's the problem here? There are actually two problems. So we have a little watch party here. So no suggestions. And also there's this hint here that this is bluish. No messages? Okay, I'll ask my guests here. So for example, these two are out of the way, like they're meant to be inside the marine reserves and outside the marine reserves. But then also this is the sea and this is outside of the sea. So basically like, yeah, observations on land, and it's all on land. So now we can see right away that something's off. And there's another question further down the line. So be ready to write your answers. Okay, so our pipeline basically has these steps like data collection, annotation, and counting process that is split into 3 steps: machine learning, citizen science, and experts. And then the data analysis and reporting step. And then I think community is really important. And this is something that came up a lot during the ICTC. And I think I've been thinking a lot since. Our process is basically the half-an-hour video goes into the machine learning, and then we funnel and give to each further steps less to review. So for the citizen science, we already select something, and then for the experts, even less. So the first step with the machine learning, we use a fine-tuned community fish detector model. And the community fish detector out of the box struggled with the images from the top. But as soon as we gave it a few images, not that many, like a few hundred, it improved really fast. And now we are adding species on top in order to have both the fish detection, but also for some of the common species like snapper and blue cod, we can get the species right away. And then we get out of it like a selection of potential maxens on this half-an-hour video. And then that gets forwarded to the citizen science platform, where people watch a video and mention like the potential maxen moment gets forwarded to the platform, and then citizen science review this and say where they see the maxen and also which species it might be. And then we have an expert review step, which we do with BIGO, which allows for a very high level review of species. So for example, this can be like a half-an-hour video, and you just see all the snapper fast, and it allows for a much quicker both a review of the values so that the scientific number is correct, but also the feedback into the models. Okay, so now is the next task. This is a 10-second videos. Can you count the fish, maxen fish on this video? I'll play it again. How many do you see? You can put it in the chat. So there's some 2s, there's a 3, some 3s, 2s, 3s. Oh, there's a 4. Okay, and then if we go forward, we can look at what our volunteers said. So some people said 5, some people said 3, then 2, then 3. Some people said spotty, some people said other animals. And so it looks kind of messy, but actually when we look at this, we see that the signal is that somewhere around second 1 or 0.1, there's a lot of activity. So we can then look at the machine learning results from there and forward it to expert review. When the video is simpler, it's less like there's less disparity. So this is one step where we're improving currently, because we don't think like this might not be the most efficient use of community, like of the community's time. So we're improving and learning from other projects on how to best see, like learn about where our model is making mistakes, and also to make it fun. What we've noticed is that the citizen science step is also an amazing tool to communicate with the community about what we do, and basically give people a chance to look underwater. And there's some rangers that actually ask to have some of their videos show always, so that when they talk to their community, they're like, yeah, look at there. and see the videos that are there. So this is actually the maxN frame. And if we look at the results, there's actually 4. So 1, 2, 3, 4. This is what the model did. So it got 3 right, and this one it got wrong, but it still found the signal. So we're doing like it's good enough to build on top of. The next step is basically to iterate on the model, make it better, and also create these scientific tools for rangers and giving back to the community, and hopefully create like where we've been building open source and modularly. But of course, it's based on the example of the Department of Conservation, but we would love it to be accessible and useful for any kind of project, marine project especially. So for me, the important thing that I like to think about a lot is who do we build for and with, and for me, and our people are basically the rangers, the Department of Conservation, then marine experts, the volunteers, the local communities, and also the general public. And one thing that became clear to me over the last few months as our pipeline improved is that before, a ranger used to have agency over the whole process. Like they would do the field work, they would do the annotations, and then the reporting, and they knew from A to Z what happened and how. Whereas now, basically, they do the field work, and then something comes out, and they know that something is happening here, and this is a bit of a mystery, and it can be basically a thing where people might lose agency. But I feel like we can maybe transform this mystery box in like a fun box and use tools to create new ways to engage with the data that was not possible before. For example, the dashboard that we saw, but then also, for example, searching through the data and saying like, show me all the sharks, or as we saw, the citizen science as a local community engagement, and then easier collaboration with researchers and so on. I know some people have in their offices things like live, laugh, love. I don't know what, but this is what is my focus, which is to see people that we work with then enjoy the tools and find them useful. It's such a great feeling. And yeah, we do. I mean, for me, it's great when people tell me what's useful and how they use it. So I try to communicate with people a lot. And there's a little data break. So this is an example of the model on our fish. And now on a little note on the International Conservation Technology Conference. So it was really, I think a lot of people found, I was talking to people, and some people actually used the words, oh, I feel like I arrived home. And it's because a lot of people we would meet and sessions we went to were really relevant to the work we're doing. And also just the networking and the exchange, everything was like useful. And the thing that really made a difference for me is that when I left, I had so much momentum to work on the project, but also because of the information and skills that we shared. And then also the interesting thing is there were so much future collaboration and sharing, like projects that we're working on now together, or even like you sign up to someone's newsletter and they say, oh, there's a conference there, and then you apply for that conference and you go there and meet again potentially. So it's really beautiful to see how coming together can make a difference. And then just a little a note on the workshop where people had to bend to look to assemble post-its. The idea was like we build tech, but when we bring it back to when we take it to the field, something happens and it doesn't work necessarily. And so we had this opportunity to bring both technologists and NGOs and everyone in this spectrum, in this world, to kind of see what happens in these projects and what might go wrong or what goes well. And I think one of the takeaways that everyone has the same problems and we just need to talk to each other, which is pretty funny. But I guess a few themes was like just funding and capacity building, and then that we have to iterate with users and community, especially like planning, scoping, learning together, and knowing local people's, like understanding local people's expertise and seeing what they need. And then the reality of the field, sometimes there's no internet or the water gets into your camera. And also that having good people on the team can make things work out, like happen, but it's also like a great motivation, and of course the need to learn from each other and share. One of my favorite titles for this was Scope Creep and Creeping Ants, because that's like the two different problems that happen, one in tech and one in the field. And yeah, this is the list of like a bunch of post-it notes of yeah, I like them because they like the problems you don't get when you sit on the computer. And then I would just want to give a two shout outs in the community. We organize some vibe coding parties, which is an opportunity to learn about the new AI tools that come. But if you are not interested in that, you can just come for a co-working session. There's like people from the conservation community. And then of course the community fish detector, they're looking for collaborators and data. So just check it out. And that's it. Thanks everyone. And yeah, thanks a lot. And thanks a lot to WildLabs.
Thank you, Kalindi, for this great presentation and for sharing all your enthusiasm.